This question should be done in round 2. It says these two equations has one common root. It is a one common root. Okay. So first of all, I subtract these two equations and get the value of x from there. So when I subtract these two equations, equation 1 and equation 2, I get the value of x from here is 9 upon p minus q minus 1. Okay. Since it is saying it is a integral root, this x has to be integer, and this can be the only common root, so this has to be the integer. This only mean that 9 upon p minus q should be an integer. It can only possible if the value of p minus q is either 1 or 3 or 9, either of the two. Let's say I place the value of p minus q is 9. 9 by 9 is 1 minus 1, 0. So in that case the value of x will come out to be 0. In this case when I place this is 3. 9 by 3 is 3 minus 1, 2. This comes out to be 2. And when I place p minus q is 1, this is 8. Now if I simplify this case, when p minus q is 9 and x is 0, I satisfy the values of, I place the value of x0 in the any of the two equations. So from here I get minus q is 1, so q is minus 1. If q is minus 1 and p minus q is 1, p minus q is 9, I can get the value of p as well, which is 8. So both of them are integers, and also p is greater than q, which is written in the question. So this is a valid case. If I talk about the second situation, when I am saying x is 2, I satisfy this is the main equation. It becomes 4 minus 2p minus q is 1. So this says 2p minus q plus q is 3. And we already know p minus q is 1. So can I say 3p is 6, the p is 2. If I know the value of p is 2, the value of q has to be minus 1 again. This is again a valid case. If I come into the third case and I say x8 is a common root, I place the common root here. It becomes 64 minus 8p minus q is 1. So I can say 8p plus q is 63, and we already know p minus q is 1 now. So this is 9p is 64. Obviously I cannot have the p integer, so it is not a valid solution. So how many valid solutions I have? 2.